All right, let's dive into a real scientific head-scratcher. You've probably heard that spiders can fly, right? But I'm willing to bet the story you think you know isn't the whole picture. The reality and the debate raging behind it is way, way stranger. I mean, it really does sound like something out of a sci-fi movie, doesn't it? These tiny little spiders just taking off, flying for hundreds of miles, sometimes even crossing oceans. It's a real thing. It's called ballooning. But the big question, the one that stumped people for ages, is how in the world do they pull that off without any wings? For the longest time, the easy answer was just, oh, it's the wind. They just catch a breeze. But then around 2018, a much cooler, more complex idea started to gain traction. The theory was that spiders were tapping into this powerful, invisible force that's all around us, electricity. And that, right there, is pretty much the official story today. So, the way this mainstream theory works is you have to picture our whole planet's atmosphere as one enormous electrical circuit. You've got something like 40,000 thunderstorms happening every single day, and they're constantly zapping the upper atmosphere, giving it a positive charge. Meanwhile, down here on the ground, the Earth's surface holds a negative charge. This difference creates, well, it's like an invisible electrical ladder stretching up into the sky, and for every meter you go up that ladder, the voltage increases by about 100 volts. Okay, so how does a spider actually use this to fly? Well, the accepted idea is pretty clever. When a spider shoots out its silk, that silk naturally picks up a negative charge. And if you remember from high school physics, what do two negative charges do? They push each other away. So the negatively charged silk repels the negatively charged ground, creating just enough of an electrostatic push to lift the spider right off its feet. Lift off. It's a really neat, tidy explanation, makes perfect sense. So, case closed, right? We can all go home? Well, not so fast. There's a physicist out there named Mathis who says this whole idea is just fundamentally wrong. He argues that the real way spiders fly has nothing to do with this, and it's all about a totally different hidden force. A force that he claims he wrote about years before anyone else was talking about electricity. And this, right here, is where things get really interesting. We're about to go down the rabbit hole on this challenging new theory. It doesn't just tweak the old idea, it completely reframes it. And it all comes with this pretty bold claim that he figured it out first. All right, so let's just look at the timeline for a second. According to Mathis, he'd been working on his idea of a rising charge field way before it was cool. He says he first published the math for it way back in 2005. Then he started applying this same theory to all sorts of other scientific mysteries. Things like weird gravitational effects during an eclipse, or even how water gets all the way to the top of a tree. It wasn't until 8 years later, in 2013, that a different physicist, Peter Gorham, first proposed that spiders use the electric field, and that's the idea that eventually became the mainstream view. And this quote really gets to the heart of his argument. He's saying, look, it's not static electricity. That's not the real cause. The real cause, he claims, is something he calls rising charge, and it's not just for spiders. He thinks this is a fundamental force behind all instances of levitation. Okay, so you're probably wondering, electric field, charge field, what's the actual difference? They sound kind of the same, right? But in this theory, they are two completely different things. They're worlds apart. So let's break down exactly what he means. This is where the two ideas completely diverge. The mainstream electric field is all about attraction and repulsion. A positive charge pulls on a negative one. But Matz's charge field is something else entirely. He describes it as a physical current, like an actual wind of photons flowing up from the Earth. He's saying it's not just moving electrons around, it's a literal upward stream of charge that can physically lift things, protons, electrons, everything. So one's a static pull, the other is a dynamic physical push. So let's just be super clear on this. What he's calling the charge field is, in his view, a constant wind of charged photons shooting up from the ground. The theory is that the Earth soaks up energy from the sun and then kind of recycles it, emitting it back out as this constant upward flow. And that photon wind, he argues, is the real engine behind levitation. And this is probably the most important distinction to grasp. In his theory, that electric field that scientists measure, it isn't the cause of the lift at all. It's just a symptom, an effect of this deeper, more fundamental charge field. He's saying we're looking at the shadow on the wall, not the thing that's actually casting it. The charge field is the thing doing all the heavy lifting. Okay, so if we're talking about a wind of charge, then how does a spider actually catch it? How do they use it to fly? Well, this leads to a totally different idea of how they pull off these incredible flights. And here's the key idea. Forget everything about electrostatic repulsion, positives repelling positives. That's not it. He says it's all about simple physical impact. To get lift, you have to physically block this rising stream of photons. They have to literally hit something to push it upwards. Think of it exactly like wind filling a sail on a boat. It's a push, not a repel. So then, what's the point of this silk? Well, in this model, it's a three-part job. First, the spider shoots out all that silk to make itself bigger, to increase its surface area so it can catch more of this wind. Second, by spreading out its mass over a huge area of silk, it makes its overall density way, way lower. And third, that web of silk then acts like a parachute or sail, physically blocking that upward flow of charge and just getting carried away by it. Okay, and this is where the theory gets kind of wild. Mathis suggests that the spider can actually manipulate molecules in its own body and its silk. It basically turns them into a one-way street for this charge, so it blocks the charge from flowing up through it, but it allows the charge to flow sideways, horizontally. In effect, the spider creates this invisible shield that blocks the vertical charge field and catches its full upward force. He literally calls it a biological levitation shield. And this isn't just some vague idea either. He actually puts a hard number to it. He calculated the upward acceleration from this charge field to be 0.0095 meters per second squared. Now, that's a tiny, tiny number compared to the pull of gravity. But the key is, he argues it's a constant upward push, always there, working against gravity all the time. So you can see this whole theory ends up being about way more than just spiders. The conclusion he comes to is that this exact same force, the one that lets a tiny spider float across the ocean, is also responsible for holding up our entire atmosphere. And he even says it helps airplanes fly. It's framed as this grand, unified theory of what he calls levitation. So whether you buy the mainstream view or this alternative theory, one thing's for sure. The simple act of a spider flying points to these incredible, powerful, invisible forces that are constantly shaping our world. It really makes you stop and wonder, doesn't it? What other huge forces might be out there, hiding in plain sight, just waiting for us to figure them out?